Okay, now getting into your derivative rules for natural log. So the first one, you're asked to take the derivative with respect to x of the natural log of x. Then that's going to be 1 over x. So this is the derivative of this, okay? Now, this rule is only applying to when you have exactly an x here in your argument, okay? Then it will be 1 over x. This rule here actually kind of covers all of your bases. So really, if you remember this one, then you can get this one as well. So instead of, well, let me say it this way. So again, you're asked to take the derivative with respect to x, but you notice they're not writing this with an x in it. They're calling it natural log of u. U is just going to represent some expression that's going to contain x, okay? So it could be that this expression is x squared. It could be that it's 2x minus 12. It could be some fraction, but they're just using the letter u to represent some other expression. Now, I just always remember this way. Of course, if I were to multiply these two things together, this is what I get, but this is just all the way I always think of it. So what you're going to do to find the derivative for the natural log of something, like I said, u is just representing something. You're first of all going to take whatever this expression is, and you're going to find its derivatives. See, it's got the prime on it, which means derivative. So you're going to take the derivative of this expression. It's going to be put in your numerator, and then whatever this expression is, just go straight to your denominator exactly as it is, okay? So let's apply this to this, okay? So this rule tells me to take the derivative of my argument. Well, what is the derivative of x? Well, the derivative of x is just 1, okay? So that gives me my 1 that's on the top. And then this rule is telling me just to write my argument in my denominator, and see here my argument just happens to be x. That's all it is, okay? So if you remember this, you can always get this rule. So it's not that you have to look at it as memorizing two different rules. Okay? So first example. Okay, just ignore this. All right, so we have f of x is equal to the natural log of 6x. Okay, so f prime of x. So we're finding our derivative. So I want u prime over u, okay? Now this is my u, this is my argument, okay? So my numerator needs to be the derivative of this. So the derivative of 6x, remember, is just 6. And then my denominator is going to be my argument of 6x. So this is u prime over u. And then this is going to simplify to be 1 over x. There's your derivative. Okay, next. Okay, so this time, of course, this whole set of parentheses right here is my argument. Okay, so all of this is my u, okay? So my numerator needs to be the derivative of this. All right, so we know that we can take the derivative of these terms individually. So using your power rule here, that would be 2 times 3, which is going to give me 6x. And of course, that would be to 1 less power. So it dropped down to be the first power. Of course, the derivative of a constant is just 0, so there's no need for me to say plus 0. So this is u prime, and then I divide that by u. So there's my derivative for that. Okay, now this one is actually going to incorporate your product rule, because the x is considered to be one function, like your first function. And see, that's being multiplied times your second function, which is your natural log. So like I said, this one you're going to have to use product rule on. Okay, so g prime of x. All right, so you're going to have your first function times the derivative of the second Okay, so this is where your new rule comes in because your second function is a natural log. So the derivative for the natural log of x would be u prime over u. So the derivative of x is 1, and then you put it over x. So first function, derivative of second function, plus second function times the derivative of the first function. Well, your first function is just x, and the derivative of x is just 1. So now take this and simplify. So what will happen here is your x's will cancel out, so that first term just simplifies to be 1. Of course, natural log of x times 1 is natural log of x. So there's your derivative. Okay, next one. Now, one thing you may be looking at here is having the exponent, and you may be thinking, well, let's take the exponent to the front. That's not going to apply here. We're going to come back and use some of those rules in just a little bit, but you wouldn't apply that rule here because this is your whole natural log. That rule applies when your exponent is just on your argument, not on the whole natural log, okay? So this one, since this whole thing's raised to the third power, you actually are going to start out by using your power rule. So you're going to do 3 times your function to 1 less power. And then you have to apply the chain rule and take the derivative of the inside. Okay, so this is the new part we've learned. The derivative for the natural log of x, okay, that would actually just be 1 over x, because the derivative of x is 1, and then you divide by that argument. Now, not anything here that you can like cancel out, but like if you wanted to, you could just take this and write it as like one big fraction, because all of this is understood to be over 1. So you could say that you have 3 times the natural log of x squared all over x. That would just be a little bit neater way of writing your answer. Okay, next one. Okay, this one is actually going to require that we use our product rule. So use, not product rule, I'm sorry, quotient rule, because I've got the fraction. Okay, so we start out with low d high. So the derivative of natural log of x is 1 over x. So low d high minus high d low. So the derivative of your denominator is just 1 all over low low. Okay, so here what's going to happen is your x's will cancel out, so you'll just be left with 1 minus the natural log of x over x squared. And there's your answer for that one.